Mathematics is a part of our daily lives. Whether it's cooking or shopping, we use it every single day. In fact, mathematics is all around us and even within us. It is a part of the human body itself. In this episode of Mathematics, we will explore various mathematical concepts, relate them to things around us, and find its applications in everyday life. To understand the concept of today's episode, let us first take a look at our own bodies. Let me ask you a few simple questions. How many heads does the human body have? Noses? Hands? Fingers in one hand? These numbers are significant because they appear frequently in nature. Let's look at the beautiful scenery around us. Have you ever noticed the mathematics in nature?
For instance, let's take a look at this tree. Look at the arrangement of the branches of the tree and count them. How many are there?
Now, let's take a look at the Bhutanese traditional houses. Observe the arrangement of windows in 2, 3, or 5. There are usually 3 rows of windows.
Here we have 5 different types of flowers. As you can see, each flower has a different number of petals. We have 3, 5, 8, 13, and 21 petals.
Now, let's take a look at this apple. Let me cut this apple in half and count the number of seeds. You will see that there are usually 3 to 5 seeds in an apple. You may have noticed that throughout our observations, there are some numbers that keep repeating. If we combine these numbers, we might get this sequence: 1, 1, 2, 3, 5, 8, 13, and so on. Now, if we look into these numbers carefully and observe the pattern, we can see that when we add the first 2 numbers, we will get the next number. For example, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and 3 plus 5 is 8, and so on. The fact that this sequence occurs so frequently in nature is quite amazing, isn't it? This sequence is called the Fibonacci sequence. We will be learning about this sequence and its occurrence in nature today. Before we define the sequence, let's delve into history to learn about Leonardo Pisano of Pisa, also known as Fibonacci, the person who discovered this wonderful sequence. He was born in about 1175 in Pisa, a Tuscan town famous for its leaning tower, but he was brought up in Bujia, Algeria. Do you know how Fibonacci got this name? It is a shortening of the Latin word Filius Bonacci, used in the title of his book Liber Abaci, which means the son of Bonaccio. His father's name was Guglielmo Bonaccio. Fibonacci studied calculation with an Arab teacher and then traveled around to Sicily, Greece, Syria, and Egypt to study even more calculation and numerical systems. Partly as a result of this, Fibonacci sometimes used the nickname of Bigolo, which may mean traveler.
During the Middle Ages, Italians were known for being the world's most proficient traders and merchants. Fibonacci grew up in a trading colony. His job was to keep track of their commercial transactions, and he was using Roman numerals, but this system was quite difficult for division, subtraction, and multiplication. After finding this problem, he learned the Hindu-Arabic system, the number system that we use today, from an Arab teacher. So, he is recognized for bringing the Hindu-Arabic system from India to Europe. In 1202, he published his knowledge in a famous book called the Liber Abaci.
The Liber Abaci showed how the Hindu-Arabic arithmetic system was better than the Roman numeral system, and it showed how the Hindu-Arabic system of arithmetic could be applied to benefit Italian merchants. Did you know that the Fibonacci sequence was the outcome of a mathematical problem? The problem was about rabbit breeding that was posed in the Liber Abaci.
Let's look at the problem graphically. Beginning with a single pair of rabbits, 1 male and 1 female, how many pairs of rabbits will be born in a year, assuming that every month each male and female rabbit gives birth to a new pair of rabbits, and the new pair of rabbits itself starts giving birth to an additional pair of rabbits after the first month of their birth. In the beginning, there is only one pair of rabbits. Let's name them pair A. Let's assume that these rabbits are newborn, meaning they cannot give birth for another month. Hence, for the next month, this will be the only pair of rabbits. In a month, the pair gives birth to a new pair of rabbits, pair B, giving us a total of 2 pairs. In another month, the original pair gives birth to another pair of rabbits, pair C, whereas pair B does not give birth for another month. This brings the total to 3 pairs of rabbits. In the next month, pair A gives birth to another pair, pair D, pair B gives birth to pair E, and pair C is unable to give birth yet. Hence, our total becomes 5 pairs. So, you may have observed a pattern in this reproduction. The pairs are following the Fibonacci sequence.
As the rabbits continue breeding, the reproduction will continue according to the Fibonacci sequence. We can define the Fibonacci sequence as when we add the 2 preceding numbers, we get the next number, like 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, and so on. Here is another interesting fact. November 23rd is celebrated as Fibonacci Day because it has the digits 1, 1, 2, 3, which is part of the sequence. In the next episode, we will learn about the golden ratio and its relation with the Fibonacci sequence. Till then, keep noticing the beautiful patterns of nature.